A common theme of statistics is that we can often never know the true mean of a large population. However, as we've seen, we can take a sample, find the mean of that, and use it as the best estimate for the population mean. The difference between the sample mean and the population mean is often never known, but it is called the sampling error. It's calculated by subtracting the sample mean minus the population mean. In example 1, the following data represents the ages in years for a random sample of people at a concert. Let's say there are 8,500 people in attendance, and 12 are selected to be part of this sample. Use the sample to find a point estimate for the true population mean. What we'd want to do here is calculate x bar, because x bar is the best estimate of the true population mean. We get approximately 22.6. Now, how close is our point estimate to the true population mean? That's something we can actually never know. So I might say it may be close, or it may not be. It depends on how representative the sample is of the overall population. Question 3 is a critical question. It says, what do you think is the approximate probability that your point estimate exactly matches the population mean for this concert? The answer is it's very low to approximately 0. We can actually have much higher confidence in our guess if we use an interval estimate instead of a point estimate. Pictured below is an example of an interval estimate. It contains a range of different values. So whereas the point estimate has a low probability of actually matching the mean, there could be a very high probability that the mean lies within this interval estimate. So as long as a sample is truly random, even if the value of x bar does not perfectly match mu, they will likely be close in value. So x bar is used as the best estimate of the mean, and it will be the center of the interval. Then we can find a margin of error E, which tells us about the size of the interval. Anytime we're creating an interval, we'll want to decide on the level of confidence, C. That tells us the probability that the interval actually contains the true mu, assuming that the estimation process is repeated a large number of times.